Question is question is if sin A is equal to sin is given as 8 upon 17, find other trigonometric ratios. If sin is given as 8 upon 17, ratio of angle A, then of course we can say, oh, hold on. As we know, it is what? P upon H. Ratio of sin theta is P upon H. It is given, which is 8 upon 17. Now meaning of this is what? P is 8 and H is 70. We don't know B. That's why we will apply Pythagoras theorem here. As you know, this is a greater number. Sum of this and sum of this will be equal to 17. So can we say, to find P, just subtract this from this clear? You will get base 17. Okay, no problem. 9 4 11 1 7 9 8 2 289 minus 64 plus not plus minus 5 2 200. So B came as a root of 225. As we know, 225 is a perfect square of 225. I think 25. It should be perfect square of 25. We can see 5 5s are okay, 2 5 2s are 10 12 2 5s are 1 more 2 2s are 4 5. No. This is how much? 675. So 2 5s are 10. This is 625. I think then 15. It is a perfect. It will be perfect square of 15. 15 multiple 15 5 5 5. So 7 1 5 5 2 2 225. So here it is a, we are confirmed that this is 225 is a perfect square of 15. Now we got B base as a 15. We clearly can find what other trigonometric ratio apart from sine. So cos A, as we know, B upon H. B is 15 upon 17. What else? 10 A. P upon B. So P is how much? 8. B is 15. Okay, no problem. What about cot A? Just opposite. 15 upon 8. What about sec? Just opposite of cos. Okay, opposite of cos. So H is 17. B is 15. Now what about cosec? As you know, it is just opposite of sine. H upon P. Now H is 17, P is 18. So we have found trigonometric ratio of angle A. Other trigonometric ratio of angle A, where sin A was given as 8 upon 17. That is how you will find value of any trigonometric ratio. Now next question. Next question is, this is complete question. What is it saying? You have given this, which is a cot theta. Cot theta is what? B upon P. B is how much? 8. B is 7. P is 8. You don't know what is the H. So as you know, sum of P and sum of B will be equal to H. So 8 8 is 64, 7 7 is 49. From this you will get hypotenuse. Now 3, I think 3, 6, 10, 11. So here you are getting hypotenuse as a under root of 130. Now we have to put the value of B, P, H in this according to requirement. Hey, hold on. A plus B, A minus B. It is a what? Algebraic identity. Can we write this as a minus B square? I think yes. So 1 minus the sine theta square. 1 minus cos theta square. It is, we applied algebraic identities. This is the first question. Now, as we know, this is 1 upon 1. Sine is how much? P upon H. 8 upon under root of 30. Like that. Clear? Now, what about this? 1 upon 1 minus cos B upon H. 1 upon 1. 8 adds 64. Only 113. 1 upon 1. 7 7s are 49 upon 130. So here 1 upon here it will become 113. 113 minus 64 is equal to upon 113 minus 49 upon 113. This will cut. We got in place of a numerator as I think 9, 10. So 4. Here 4, 10, 6. 7 7s are 8 8s are 7 upon 8. Till here it is a correct. What did I do? I found hypotenuse, then I applied algebraic identities in this. Then here I put value of H, value of P, value of B according to requirement. Then I simplified it further. I got 7 upon 8. It is a code. Wow. Now next question. This is complete question. It is saying, it is saying in triangle OPQ, where triangle is a right angle is at P. Here you can see this right angle is at P. OP is a 7 centimeter. OQ, where is OQ minus PQ will give you how much? 1 centimeter. Will give you this much. Determine the values of the sine Q, this sine Q and cos Q. Sine Q and cos Q. We don't know what is a perpendicular, what is a this, that. If OP is this much and it is this is 1, can we say if this is 1, then this will be here. From here we can find what? OQ 1 plus PQ. Yes, it is happening. Now OQ is how much? So easily we can say, OQ is 1 plus PQ. Okay, and if this much, then PQ will be 1 minus OQ. It will be 1 minus OQ. What is happening? So here, as we know, if this is a right angle, so of course OQ will be hypotenuse. So OQ square, okay. No. Then PQ plus PO square. Yes, this is happening. OQ will now 1 plus PQ square. And PQ is how much? I think 1 minus OQ, it should be 1 minus OQ. And PQ square. PQ square plus PO. PO is how much? 7 centimeter. 7 centimeter. 1 plus 2 PQ plus PQ square. PQ square plus 49. Now here 2 PQ, this will cut, and here 49 minus 48. PQ came as a 48 upon 2, 24. PQ came as a 24. Where is the PQ? PQ is this. This came as a 24. If this came as a 24, we can say, as we know, OQ will be what? 1 plus 24. So OQ will be 25. So it is a 25 centimeter. Here, that's how we found. That's how we found. Now we can easily say that it is a what? It is a base according to this. No. According to this, this is perpendicular. This is base. This is hypotenuse. According to Q. So sine Q, as we know, P upon H. Cos Q, as we know, B upon H. But according to Q, this is perpendicular. 7 upon 25. Base how much? 24 upon 25. Clear? Here, this is complete answer. This is what? Complete answer. Yes, it is correct. Now next question. Next question. This is next question. It is a very easy. Just put a value of sin 60, value of cos 30, whatever you know, but those ratio should be right. Let's put. We have to substitute sin 60, cos 30, cos 60 multiple sin 30. Now sin 30 is what? Value of sin 30 is root 3 upon 2 multiple cos 30 root 3 upon 2. Cos 60 1 by 2 sin 30 1 by 2. Now here, from here we are getting 3 upon 2. 3 3 is 9. 9 is the perfect square of 3. Now only 2 1. Now we have fraction 2. Okay, 2. 3 minus 1. So here finally we got 1. After substituting, after putting values of H ratios, we got answer as a 1. That's how you will solve. Now next question. This is computation. What is it asking? Even I don't know answer of this question. So in triangle PQR, okay, in triangle PQR, which is here, right angle at Q, right angle at Q. PQ is 3 centimeter, PR is 6 centimeter. Determine angle QPR. Where is QPR? QPR. This one, and PRQ. This one. We have to determine. How to determine? Okay, if this is happening, do we know value of this, measure of this? If this is a right angle is at Q, then we can easily say that QR will be what? 6x square, 6 square minus 3 square. Clear? QR 36 minus 3 is 9. QR 24. 36 minus 9. What is happening? 36. So 7 and 2. 27. 27. Here, if we take this, now, if we don't care about this, then we have what? This. As you know, if we take this, our angle, we are taking P angle, okay? We are taking P angle. And we are clear that right angle is at Q. Right angle is at Q. If right angle is at Q, then this is a perpendicular and this is a hypotenuse, isn't it? Now, according to this theta, it will be perpendicular. This will be base. So base upon h is a ratio of cos theta. B upon h. B is 3 upon 6. It is giving 1 upon 2. So finally cos theta came as 1 upon 2. As you know, cos theta is equal to 1 upon 2. How much degree of cos theta gives you 1 upon 2? You would say cos 60 degree gives us 1 upon 2. So theta, so here theta is what? 60. Otherwise here you can find cos theta, okay? Cos theta, and this is how much? Cos 60, isn't it? Cos will cut, theta came as a 60. You can find like that. From this you can find like that. Now what else? So theta is what? This theta is 60 degree. What about this? If we take this, then this will be perpendicular and this will be hypotenuse. So then we will take what? Sin theta 3 upon 6. Again 1 upon 2. Sin theta 1 upon 2 is a ratio of sin 30. Sin 30. So here sin will cut, theta will come as a 30. So this is how much? This is how much? 30. Clear? Even you can check 60 30 90 and this 90. So sum of interior angles of a triangle is giving 180. Okay. Now next thing, remember trigonometric identities. Remember, okay? Here cos square theta plus sin square theta will give you 1 plus tan square theta will give you sec square theta. 1 plus cot square theta will give you cosec square theta. These are trigonometric identities. By applying this, we can save our time. I am taking one question based on this trigonometric identities. This is question, okay? This is control question. Now look at this question. 3x is equal to cosec theta. What is happening? Find the value of this. That. If cot theta is equal to 3 upon x, it means B is how much? B upon H. B is 3. H is x. Find the value of this. Here can you say cot theta plus cosec theta 3x plus 3 upon x. If we take like this, and we are getting what? From this we can get cot square 1 is equal to cosec square theta minus cot square theta. If we subtract, then cosec theta minus cot square theta. Okay. What else? Three x square minus 3 upon x square. Okay, clear. From this we will get value of x, and this is what we want. Here it will convert into 1. 3 3s are 9. x square minus 3 3 is 9 x square. Here we have this 1 upon 1 x square. Now here 9x square 4 and this 9. Clear? X square is equal to 9x 4 minus 9. X square minus 9x 4 is equal to how much? Minus 9. This is that. Here you can see we can take what 1 is equal to 9 x4 minus 1 upon x2, isn't it? But rather than doing like that, we can do what cosec square theta minus cot square theta, it becomes 1 as we know. Now here we are putting value of this and value of this. Value of this is this much. Value of this is 3 upon x, this much. 1. Okay. 3 3 is a 9x square minus 3 3 is a 9 x square. Again same. Same. Here 9 is a common. X square minus 1 upon x square. 1. This is what? Here we got this x square minus 1 upon x square 1 upon 9. We want this 3. This is side, this is complete. Just we will multiply 3. We will multiply this by 3 and this by 3. 3x square minus, okay, 1 by 3 3 is a 9. So finally we got this. One upon 3, this is answer. Find the value of this that. Now next question. You have to prove this. This side should be equal to this. If you take this, then as you know, I have erased it here. Now here, look at this. 1 minus sine of square theta. If here cos square, yes of course, it is giving us how much? Sine square. Now you can remember that sine square plus cos square will give you 1. Will give you 1. Sec square theta is equal to 1. It will give you cos square theta. Okay. 1 plus tan square. So you can say sec square minus tan square theta is equal to sec square minus 1. Now into sec square. As we know, it can be written as 1 upon cos square theta, isn't it? It will cut. So finally, both sides are equal. So we have proved. Next question. This is conversion. Now it is telling you we will solve this. Okay, we will solve this. Here we can write it as a 1 upon sin theta minus cosec theta cos theta minus sec theta. Okay, sec theta. Now we can do is that 1 upon cos 1 upon cos here 1 upon sine 1 upon sine. Here is it correct or not? Cos it is what 1 upon sine minus 1 upon cos. Here it is it correct or not? No, this is not correct. It will be as it, and this will be as it. Okay, here I was confused. Now here we have fraction. Like that. So here it will be sine square theta, isn't it? Only one. In this bracket, what will happen? This cos theta. Okay, cos 1 is a cos, so cos square theta minus this both are same. That's why this will be as it. Now here it is sine square plus cos square is equal to 1. So here sine square minus 1. Of course, it will give you cos square theta upon sine theta. Okay, clear? Now into sine square theta upon cos theta. Okay. Now here what can we do? As you can see, this we have cos theta into sine theta. Cos theta into sine theta. Now what about this? What about this? It is telling you 1 upon tan. So sin theta upon cos theta. Clear? Now plus this cos theta upon sin theta. Now here 1 upon cos theta into sin theta. Clear? No problem. Clear? So yeah, it is the same. We will multiply this with this sin square theta plus here this is sin, this is sin. So we will multiply this by this cos square theta. Till here I can confidently say that it is a correct. Now 1. So here what is happening? What is happening? This one and this is what? Here we can apply algebra trigonometric identities. This is equal to 1. This is equal to 1. 1 upon cos theta into sin theta. Clear? Now as you know, this whole is in place of denominator. When we will write here, then it will convert into so position of numerator and denominator of this fraction will be opposite. Cos theta into sin theta. Now you can see this both are equal. So this was RHS and this was LHS. So finally we can see that LHS is equals to RHS. Clear? I think you are clear. Just have a look. Now next question. Next is prove that sin theta minus 2 sin cube theta 2 cos this is equation we have to prove. Now it is easy. Here sine, okay. Here we are observing this 3. Why did this come? Here Here we can take what sine as a common. Here we can take a cot, not cot. This is cos. Cos. We can take here sine as a common. Here cos as a common. So sine. Then 1 minus 2 sine square theta, isn't it? And in this cos 2 cos square theta minus 1. This is happening. This is what it is happening. Now what else? What else? Here you can use algebraic identities. You can use algebraic identity of sine square plus cos square theta. Sine theta, okay, here, okay, here. Sine square theta plus cos square theta minus 2 sine square theta. By doing that, you will get what? You will get this will cut by this, then we will have this. That's one. Cos theta. Here we applied what? Algebraic identities of sine square theta plus cos square theta. Now, yes, same here. 2 cos square theta minus here. How much? I think cos square theta plus sine square theta. Yes, sine theta upon cos theta. Here you can cut I think this, then we will have only one, and here we will have only one. You can write 1 plus cos square theta. Clear? What is happening? Here you will get plus 1, not a minus 1. So 1 plus sine square theta. Now again you can use algebraic identities. As you know, 1 plus cos square theta will be equal to sine square theta. You know sine square theta. Cos theta multiple this will be equal to cos square theta. Cos square theta. Again we applied here algebraic identities of this. Now from this I want to write this here. Here, what is happening, brother? What is happening? I did wrong. Yes, it is correct. This is correct. Then I did wrong. Here I did wrong. Not 1. Not 1. Here we are getting this cos square theta, this, and minus sine square theta. And here from this we are getting what I think cos square theta plus sin square theta, isn't it? Cos square minus so here it will be minus and this will be plus. Then we can write like that. What is happening? If we subtract this from this, then we will get minus sin square. Okay. If we subtract this from this, then we will get this, and this is what? Plus, and here it should be minus. It should be minus. Then this will cut and we have tan theta. Here this is correct answer. Now next question. We have this. You can take this to come to bring this RHS. Even you can take this to bring this LHS. So I am starting from here, from this. I am starting from this. Can I write it 1 upon cos square theta? Yes, 1 upon sin square theta, sin square theta. Yes, here I am getting what? Cos square theta into sin square theta, isn't it? Yes, of course. What else? Here I think this is same, so this is not. So I will write here this, and this is both are same. So I will write this here. Now I know that this is equal to 1 in trigonometric entities. So I will write here 1. This is this much cos square theta into sin square theta. Now I have to bring this. I have to bring this. I know this is equal to this plus 1 upon sin square. From this I am getting what? Sec a square theta plus cosec a square theta. This is final answer. We have proved. We have proved. Hold on, it is a what? N2. And here, this will not be N2. This will be cosec square theta. This is answer. And here N2. 1 upon sin a square theta. 1 upon sin a square theta. This is answer. So we have proved this LHS is equals to RHS. Now next question. Okay, this is completion. I am starting from this to bring this. As we know, sec square theta can be written as 1 upon cos square theta. Cos square theta. It can be written as 1 upon sin a square theta. 1 upon sin a square theta. Clear? What else? Here is what? Cos square theta into sin a square theta. Okay, sin a square theta, isn't it? Yes. Till here it is a correct. Now this is the same. So I can write this here, this. Okay. This is same. So I can write here this. Clear? Now what else? What else? Yes, this is equal to 1. As we know, 1 upon cos square theta into sin square theta. Clear? What else? What else? What else? Then again it will come same. As you know, it can be written as 2 square. Yes. So we have now what? 1 upon cos theta into sin theta into sin theta. Yes. Now here 1 upon cos theta into 1 upon sin theta will give you this sec theta into cosec theta. Clear? Now this RHS tan theta plus cot theta, tan theta plus cot theta. As you know, sin theta upon cos theta plus cos theta upon sin theta. We can take the LCM. So sin theta, cos theta. Okay. Here cos theta, this are same. We will multiply this by this. Sin square theta plus this is same. This is same. So we will multiply this by this. We will get this much. Clear? As we know, this is equal to 1 sin theta into cos theta. We can write like that: sin theta into 1 upon cos theta, 1 upon cos theta. From this, we are getting what? This is I think cosec theta. I think cosec theta into sec theta. You can write this like that: cosec theta. Answer will be same. So here this was LHS and this is RHS. So finally you can say LHS is equals to RHS. We have proved. We have proved. Now next question. Apart from this, Next question apart from this. Now next question. This is complete question. This is what? It is a complete question. Now it is saying that this is equal to this. If we take this x square plus y square, then it is saying that in place of x we know value of x, we know value of y, we know. Just put a square sin theta plus b cos theta. This is in a square plus. Okay. Now here what else? This b sin theta. This is in a square. Okay, we have substituted value of x and value of y. That's it. Now next, we know that this is a plus b square, isn't it? This is a plus b square. So a sin theta square plus 2a sin theta into b cos theta. What else? b cos square theta. This is what next. A cos square theta plus not plus, minus 2a cos theta b sin theta, then plus b sin square theta. Clear? It is clear. Now if you remove this bracket, then you get what? This and I think this. What is happening? So remember, this is this much. Now here from this not this is cutting, isn't it? It is a cutting, but here this and this we can take a square common, sine a square theta, okay, sine a square theta plus cos a square theta. We took a square common, a square as a common. Now what about this and this? Not this and this and this. Same here. B a square, okay. Hold on, what is happening? Here A and here B. So yes, we will take this and this. It is correct. Not this, okay. B a square cos a square theta plus sine a square theta. Here this is correct. Now a square plus b a square. This is 1, as you know. This is 1 plus b a square multiple 1. So finally we have proved that this is equal to this. X square plus y square, x square plus y square is equal to a square plus b square. So this is the final answer. So that's all. That's all.